well, anytime you're joining webs, multiple webs together in a lamination, curl and puckers can occur for a variety of reasons. One reason is you join, in this example, a couple of layers together where they're basically starting at different lengths, so they have different strains when you stretch them to the same length, or you stretch the short one to the same length as the long layer. And when you let go of those, if they're joined together, it will curl towards the shorter side. So the strain of the web and the webs not being matched at lamination can cause you some curl or puckering. You can also have, things like humidity or temperature changes from one layer to another. You can have shrinkage or curing of a coating differently on one layer than another. So there's a number of different reasons for curl occurring. So let's take a look at one example in using the library, the web handling library. In this example, we have 3 webs. They have different modulus, which is the slope of the stress strain curve, sort of the slope of that. In this case, the top web is the highest modulus web. The lowest modulus web is in between, web number 2. It's half the modulus. And web 3 is in between those two. But in this initial example, we're going to pull all these webs with the lamination nip and wind up this laminate on a winding roll. And we're going to start off with the same breaking torque on each unwind. And they're all the same, all equal and constant during the simulation. So here's how this gets represented in MapleSim's web handling library. We have the 3 webs, web 1, 2, and 3. They each have a break on the unwind with a fixed breaking torque. They come together into a lamination nip. Each web has its own property block, and then there is a laminated web property block, which basically uses a rule of mixtures formulation to calculate what this laminated web property is going to be. And then we run it into a rewind, and we can look at things like the strain at this lamination nip as an output in the simulation. So let's take a look at this in this 20-second simulation. You see some transient behavior there at the beginning. Because of the way the rolls are being ramped, we get a peak in the strain. We're outputting the actual web strain here, which is something nice you can do in a simulation. And you can see that there's a difference in strain at this combining point. Web 2 having the highest strain, web 1 having the lowest strain. This model isn't going to predict curl, but it is going to say that you don't have equal strain at combining. And that may be something you want to try to fix. So in order to account for all the different moduli of these webs, we can try reducing the breaking torque by half for web 2. We could reduce it by 1/4 for web 3. And let's just see if the simulation gives us what we would expect, which is yes, because we've matched the strains now, because we've accounted for the different moduli that we have in the simulation, we are effectively at an equal strain at combining.